Particle is executing a simple harmonic motion with the amplitude A. And the question here is at which displacement value the potential and kinetic energy of a particle remains same. It's known that during a simple harmonic motion, the kinetic energy will be equal to the potential energy. So based on this only we are going to solve this question. For this, first we need a value of kinetic and potential energy. For that, we are going to use a concept of total energy in a simple harmonic motion. It's known that in simple harmonic motion, the total energy of a particle is constant and it will be equal to the sum of kinetic energy and potential energy. It's known that the total energy of simple harmonic motion is half Ka square, whereas the potential energy is equals to half Kx square. So based on the relation of energy, E is equal potential energy plus kinetic energy. We can calculate the value of kinetic energy. So kinetic energy will be equal to E minus potential energy. So the kinetic energy will be equal to half Ka square minus half Kx square. So here we can write the kinetic energy will be equal to half Ka square minus x square. And as I said already, the kinetic energy will be equal to potential energy. So we have a kinetic and potential energy. Let us equalize this value. So half K a square minus x square will be equal to half ax square. When we are simplifying the similar terms, we will get a square minus x square is equal x square. So here again we can write a square will be equal to 2x square, and here we need a value of displacement ex, so we can write x square will be equal to a square divided by 2, and from this we can write x will be equal to a divided by root 2. So the correct answer for this question is option C.